everybody, this is Mrs. Dinkelman, and these are the notes for 8.2 where we're finding the area between two curves. So we have already found area underneath a curve where we just do, and you can see here Gary's talking about, where we just do the integral from a to b of f of x dx. And that does produce what's called a signed area where we can get like this net thing occurring. However, when we have if we want to just find total area, we want to make sure that's not negative. That's just what he's mentioning up there. Now, when we find the area between two curves, we don't have to worry about the fact that some might go negative because we are always going to do the top curve minus the bottom curve. So if we were to have something negative, that minus a negative is going to cancel something out. So if you're the highlighting type of person, I would highlight that just like Gary has. We're going to always make sure that we do the top minus the bottom. And if we think about the rectangles that we did before, I always like to think about kind of a rectangle in here. If I wanted to know how tall that rectangle is, I would have to do the top minus the bottom to figure that out. So hopefully it makes sense that to find the height of that rectangle, we would need to do that anyhow. We can also sometimes, if needed, we can turn our head on our side, and sometimes we have to do that just because of the way that they gave us the curves. But we can think of right minus left, and I'll show you. I had a calculus professor who used to just draw pictures for me all the time, and so I'll draw that if I need to. So on this problem, example 1, we're going from 0 to 1, and the top curve looks like the parabola. Nice that we have a picture. Sometimes it's a little trickier to tell, and the bottom curve is that line. So that's the setup, and let's just for practice make sure that we know how to find those integrals. So we'll simplify in here a little bit first. So that's just going to be actually x squared. And so we'll get x cubed over 3. And then we'll just get 1/3 minus 0, but 1/3. So sometimes what he's saying here is sometimes we have to find the boundaries because it's not as obvious. So let's see what this one's going to look like. First of all, this is where my professor would always draw this weird little dude on his side so that you know basically to put your right ear on your right shoulder, and that this would then be a parabola moved down 3. But again, you have to have your ear on your shoulder to know that that's the case. So I'm not going to be careful about where this crosses the x-axis right now. And then x plus 1 is this line that's going to go like this. So we need to know where these intersect. And we're going to talk about, I think this one should be done kind of on our side as well. We'll talk about that in a second. But let's try to first figure out where these intersect. And I think what I'm going to do is solve this guy for x. So x equals y plus 1. If I just kind of exchange, that's not true, y minus 1. I was just going to exchange them, but that doesn't work. Okay, so just subtract the 1 over. So now let's set y squared minus 3, so that x equal to the other x. And then we'll do some solving in here. This is where our factoring comes into play again. So y minus 2, y plus 1. So it looks like we get y equals -1 and positive 2. And we can just double check if that makes sense. Again, I didn't do a good job of drawing it, so it's ish. It looks sort of good. I'm going to leave those as, again, -1 and 2. Because I think instead of thinking like we normally do left to right, is I'm going to think of this guy with his right ear on his right shoulder. So I'm going to think of my rectangle as being sideways in this case. Okay, so that's what Gary was talking about doing right minus left. But if I turn my head on my shoulder, then I can still think about top minus bottom. In that case, what I have to do is I have to do this in terms of y. And here's kind of the reason. Over here, the width of the rectangle is based on the horizontal component, which is the x, or the dx. Now, the width of that rectangle is based on the vertical component, so that's a dy. So I'm going to do this integral from lowest y to highest y. I'll have a dy at the end. And again, if I put my right ear on my right shoulder, I can think of top minus bottom. So the top, or the right-hand side, is the line, but I need it in terms of y. And then the bottom, or again, you can think of the left, is that parabola. Now, let's think about what happens if we don't do it that way. So let's say we try to do rectangles in the direction that our brain normally wants us to do. Well, this rectangle that I have to draw here, I want you to think of it as movable. Okay, so if I draw it there, the weird thing is that the top and the bottom are the same function. They're both that parabola. If I move that and bring it over here, then the top is the parabola, but the bottom is the line. So I can do this in this way, but I'm going to have to do two separate integrals. I have to think of this parabola as two separate functions so that I can do top minus bottom. And that just seems like more work than just turning it on our side and doing kind of the same thing we would normally in terms of x, but now just with a y. Okay? All right, so let's go ahead and practice here. So this is going to be, I like to write it in order, negative y squared plus y, and then it's going to be actually plus 2. Let's make sure that looks right. Positive 3 minus, okay, I think it looks good. You guys can let me know if you think I did it wrong there. So antiderivative, and then we're going to plug in our pieces. Unfortunately, there's not a 0 this time. Okay, so we're going to have negative 8 thirds plus 4 minus, and then that'll be a positive 1/3 with the negative 1 in there, plus a half minus 2. Okay, what my brain sometimes does is start collecting. So like there's a negative 8 thirds and a negative 1/3, so that's negative 9 thirds, which is really nice because that's a negative 3. And here I have an 8, and then I have a minus a half and plus a 2. So I'm going to call this plus 10 minus a half. So 7 minus a half. And then you can always convert that if you want. Okay, now sometimes something like example 3 happens where it kind of switches what's on top and what's on bottom. So based on the picture, to me it looks like that guy is the cubic. Okay, he looks like he goes like this. Okay, and then we have this parabola right here. So this is the negative x squared plus 4.1x. And based on the fact that it's a 4.1 tells me we're probably going to get to use our calculator here. A couple things on our calculator. We're going to have to figure out where they intersect. So we can do that in a couple ways. 89 people. You can go to the F2 Algebra tab and you can do the solve feature and just set the two equal to each other. I'm going to pretend like I have an 84 because all of us can do this in this way. So I'm just going to go x cubed minus x squared. That's the first function. Just make sure it looks right. And then negative x squared plus 4.1x. Okay, let's make sure that looks good. Okay, and then I don't even know what kind of window I'm in. Looks pretty good. Okay, so it looks to me like they definitely cross at that 0, 0, so that's helpful to know. I am going to have to split this integral into two because, again, the top and the bottom flip-flop from one to the other. So I'm going to have to do this integral from something to 0, where, again, I think the cubic is on top. Okay, so that'll be the first half, and then the second half is going to be from 0 to something, and then they flip-flop. Okay, so let's figure out those starts and ends here. Okay, so I'm going to find this intersection up here just because it looks like I might have to change my window for that second one. So go to your either calculator or math. We're looking for the intersection. Quick reminder, it's going to ask you, is this the first curve? And you can just hit enter and it'll jump to the second curve. The only time that that's important is if you had like 3 curves on there. So it wants us to go a little bit to the left and a little bit to the right, so it knows exactly which one. And that looks like 2.025. Okay. And then, let's see, I'm going to go ahead and change my window here. I just need to have a little bit more on that y-axis. So let's go negative 20 there and see if that's enough. Oops, I didn't want the table. If that's enough to see that intersection there. So again, calculate or math, intersection. Again, it's going to ask first curve, second curve. I'm just hitting enter on those. And then I need to go a little bit to the left of it. That looks good. And a little bit to the right of it. Okay, so negative 2.0. That's nice. Maybe we should have known that, but I don't know based on my brain. It doesn't look totally symmetrical, but maybe that's just how it was drawn. Okay, this is a good time to practice making sure that you have the integral stuff right. So if you want to pause and double check, you're welcome to do that. And then roll around and see if you have the right answer. So it's going to take a little bit of typing here. Again, you can also completely ignore. I guess the other thing that's interesting is, again, I have the cubic in Y1, and you could do this on the 84 as well. You just have to go to the VARs tab and find Y-vars. Okay, so in Y1 is the cubic. So I'm doing the cubic minus the parabola. And again, notice how I'm using sort of like f of x notation just with y1 and y2. Comma x, comma, negative 2.025. Now we might actually want to go more decimals on that just to verify, because if we're rounding here, then we're definitely going to have a rounding error later. So just be careful about that. Especially on the multiple choice, if yours isn't quite right, that could be the issue. Okay, on this one, they flip-flop. So now y2 is on top and y1 is on the bottom. Again, we always do top minus bottom. And then this one is 0, 2. Okay, and then we'll hit enter and let it roll around. Okay, so it looks like 8.405. Let me know, as always, if you're having issues with that calculator. All right, for some reason I thought there was one more, but that's good. Okay, so again, a quick reminder, sometimes it's just normal in terms of x, there's top minus bottom. Sometimes we have to do right minus left, again, or if you put your head on your side like that weird little dude, and then just make sure everything's in terms of y, so that we use the y coordinates and all the equations in y. And then sometimes, unfortunately, the top and bottom flip-flop, so we have to write a couple different integrals there.